And let me then, what was the special line that we learned about last week that goes right through the center of the circle? What is the special line that goes right through the center of the circle? Mark? Mark, you're muted. I want everybody to unmute themselves. So when I call, you can just answer the question as opposed to talking and then you can't talk and then I have to say that you're muted. Okay, so everybody unmute themselves. Sarah, Alexander, Raymond, Jesse, Gabby, Sarah, Raymond, Jesse, Gabby. Unmute themselves, please. Raymond, Jesse, Raymond, Jesse. Now Raymond, now just Raymond. Raymond, unmute, unmute, and Jesse, unmute. Okay, great. Go ahead, Mark.
The diameter. Diameter.
Right, guys, everybody say it. It is the diameter. Now, what is it called if I only go halfway from the center out to the circle? What is it called then, Brennan?
Circumference.
Well, we learned that the circumference was the perimeter. And remember, there were pi diameters that fit around the perimeter of the circle. So this black segment that is a part of the diameter is not the circumference. Who thinks that they know that? Kelsey, your hand is up. Do you know it? Or was it up from before? No, Sunyi, what about you? Does anybody know the name of that segment? Go ahead, Sunyi.
Radius?
Yes.
Yes.
It is the radius. It is called the radius. Now, if I told you that diameter was represented by the letter D and radius was represented by the letter R, in order for me to make this sentence true, what would I have to do to one of these? I would have to multiply one of these by a certain number. Who can answer that? Raise your hand if you think you know. I'm going to go with Gabby.
I was thinking, well, you have to multiply the radius by 2 to get the diameter.
Right. So you multiply the radius by 2, everybody. Now, is there a different answer to the same question that would also make it work, where I have D equals R, but of course, diameter does not equal radius? What can I do, Jesse?
It can be D divided by 2.
We can also divide the diameter by 2, everybody, to get the radius. So what if I tell you all that so we're gonna make a little chart, okay? We're gonna make a little chart. Diameter and radius. Are you ready?
This is half the diameter.
Now.
So what do you multiply by the radius? Try to get the diameter. Citizen.
Okay, so Will, why don't you listen to this, buddy? Will, if the diameter was 10, and we know that the diameter divided by 2 equals the radius, or the diameter equals 2 radius or radii. William, how long do you think the radius is? You'll have to unmute yourself.
10 divided by 2 is 5, so that means the radius is 5.
And that is correct. The radius is 5. Now, what if the diameter is 30? Everybody on 3. 1, 2, 3, go.
15. 15.
What if the diameter is 3. On 3.
1.5.
1, 2, 3, go.
1.5.
Or
1.5.
I just like to say 3/2. I mean, isn't it just easier to just say 3/2? Which of course, you are correct, is 1.5. Now, what about 37? Don't answer out loud yet. Think about it, write it down. Think of 26 plus 1,
Write it down.
partition them.
No, what's the radius if the diameter is 37?
And on 3, everybody. On 3, 1, 2, 3, go.
18.5.
18.5.
18.5, or wouldn't it be just easier to say 37/2? It's so cool when we can just use fractions. Now, one of the things I want to make sure is if I give you a diameter of some number like, let's do an easy one. Let's do 246,802. If the diameter is 246,802, the radius, wouldn't I need to divide that diameter by 2?
Mhm.
And I want everybody to write down 246,802 and then make a little division sign and put a 2 there. And when you look up, I'll know that you're ready. Sarah, have you already written that down? Because Sarah, you're a lefty? If you are a lefty, okay, then your hand was on, so you got to write it down. You got to write it down. As fast as I say it, you write it. And now.
Mr.
Yeah, you have a question, Mark? Don't give the answer yet, but don't give the answer yet. But if you have a question, I want to hear it.
I think I sent you a chat.
Okay, you can do that. Now, everybody, 2 goes into 2. How many times? Go.
1.
1.
2 goes into 4.
2.
2 goes into 6.
3.
3.
2 goes into 8.
4.
2 goes into 0.
0.
2 goes into 2.
1.
1.
Answer?
126,401.
Now, what happens if the diameter equals 123,401? Now, when I write out that number, Sarah, have you written it yet? Make sure you write it as I write it. We're now going to divide that by 2. This is going to be a little more challenging. Now, we're going to do this in a way that I think is a little messy, but I want to show you first. Does 2 go into 1 evenly, guys?
No.
No.
So how many times does 2 go into 1 evenly?
0.
0.
But we never used the 1. So do you see that we have a remainder of 1?
Yeah.
Put that little 1 next to the 2. Put that little 1 next to the 2. Now, everybody, 2 goes into what number? Gabby, 2 goes into what number? Gabby, 2 goes into what number?
12. 6 times, but I thought if you can't get it evenly into the first number, don't you take the first two then don't you take the first two numbers and make that into one number?
Right. So guys, do we really need that 0? Can't we just
No.
look at it and say 1 is too small? Let's do 2 goes into 12 6 times. And so now I'm going to erase that. I'm going to erase that. And we don't even need the remainder. We can just say 2 goes into 12 6 times. But you have to put the number 6 above the 2, not above the 1. And definitely not in between. 2 goes into 12 6 times. Now, everybody, 2 goes into 3. Go.
1.
1.
But now you have to say, but remainder 1.
1.
Now, 2 goes into 14.
7.
Everybody say it.
7.
7.
2 goes into 0.
0.
0.
2 goes into 1.
0.
0.
With how much left over?
1.
1.
1 what?
1.
And the answer, everybody, is 61,701 half. And that is the radius if the diameter is 123,401. Does anybody have any questions on how we divided that odd number by 2 before we move on? Does anybody have any questions? Nobody. Okay,
No.
great. Now, one of the
No,
really
Kramer.
yes,
Mr.
yes,
Kramer,
yes,
I have a question.
yes, honey.
But are we would that? Oh, never mind. Actually, wait. No,
No, ask the question.
no. I actually have my question now. Wait. Wait, the radius and the diameter are the exact same?
Well, what I did, which is kind of interesting, Gabby, is that I took a really big circle and I said, let the diameter be a certain number. Then I took and I said, wait a minute, what if that radius, and I don't like that picture as much. I'm going to move it over just slightly. What if my new diameter was the same as my old radius?
Oh,
But
That
then could I keep going?
Yep.
yes.
And look at that, guys. Could I keep going?
Yeah.
Yep.
Could I keep going?
Yeah.
You can keep going on forever. Just you would have to make smaller circles.
Yeah.
Yeah, and at one point, what I find interesting is that I think that's about all we can do.
It looks like it's the inside of an ice cream cone.
So
Sort of.
so I like
tunnel.
I like what you just said. Now,
Yeah.
what I'm gonna
It's a
do
lot like
here,
a tunnel.
I'm gonna give you the diameter of the big circle. And I'm gonna tell you that the diameter of the big circle is 32 inches. What is the radius of the smallest circle? Now, don't anybody say it out loud. I want everybody thinking about it.
I got it.
Good. You can send me a chat. I agree with Jesse. And Sarah, can you say, oh, Sarah, you have a question?
Yeah.
Go for it, honey.
So if I know, how would I figure out the smallest circle if I don't know what any of the other circles are?
Well, we know that the diameter of the first circle is 32. So therefore, the diameter of the second circle must be what? What is the diameter of the second circle? Sarah, if the diameter of the first circle is 32 and the diameter of the second circle is half of that,
16.
what do you think? Very good. Now you should be on your way.
Okay.
Oh, Mark got it. Kelsey, question?
Some people are accidentally sending it to everyone instead of just to you. So
Oh,
Yeah,
yes,
you
yes,
didn't
yes.
make everybody only be able to send to you.
Yep, that was my mistake. Thank you very much. 8, 4, 2, 1. So I don't know. I actually, wait a minute. I think I agree with William. I think I agree with William here. So what do you guys think it is?
2.
You think
1.
it's 2.
1.
And William, could you make your argument why you think it's 1/2?
Because there are more than the circles that you see. There's one like in the middle.
Yeah, but
of that.
why is the radius of the smallest circle 1/2? That is the critical question.
Because it's half of 1.
Right, and how do you know that the diameter of the smallest circle is 1?
Because if you count down by halves, the biggest would be 32, then 16, then 18, like on and on.
No, not 18. Come on,
8.
Will.
I think he meant 8.
8,
Keep going, buddy. Keep going.
4,
Keep going.
2,
Keep going.
1.
So the diameter, everybody, of the smallest circle equals 1, which means the radius equals 1/2. And that was really, really well done. Almost, there was nobody that got that right except for one person. And it's really, really hard, really hard to do those questions. Now, let's talk about something a little bit different. If I know that, and let me just sort of actually show you. Let's go to page 7 in your document. So everybody go to page 7. And there should be a circle with a radius of 4. Now, what I did, everybody, is I drew a circle with a radius of 4 on a square grid. And then I tried to say, how many square units go into that circle? Why do you think I didn't count the blue ones? Who can tell me why I didn't count the blue ones? Penny?
Because they're not like full squares.
Right. But why, for instance, did I count the ones that have the number 3 in it the number 8, the number 42, the number 37. Those aren't full squares either, but I still counted those. Who can tell me why? Raymond, are you raising your hand, buddy? I can't tell. No? Let's go with Sarah on this one.
Is it because they're not fully squares?
Right, but I did count them because they're almost. And Gabby?
So I was going to say is that they're almost full squares. So
Right.
and that's why if you look really closely, that when you wrote down your final answer, 50 and 2/7 inches, you have the about sign before it, not the equal sign.
Right. That's a very, very good observation, Gabby. Now, guys, I want everybody to look at the squares that are numbered 1 and 2, 15 and 23, 22 and 30, 43 and 44. Are those full squares? Who can raise their hand and answer that? Go ahead, Brennan.
Not quite, but very, very close.
Yeah. So I counted those two. Mark, you had something to add?
No, it's the same thing as Brennan.
Now, guys, the coolest thing about the area of a circle is that the formula is that the area equals pi times the radius squared. Now, not everybody knows the concept of square. Alexander, can you tell us a little bit about what happens when you square a number? And I can't see you, so if you can angle your computer down slightly, that would be awesome. Or maybe sit up a little bit. And Antarisk, I'm going to call on you if Alexander doesn't unmute himself. But you're going to need to unmute yourself, buddy.
Okay. Squaring something out is I think it's trying to find a cubic shape and trying to figure out the problem by using squares, I guess.
Well, yeah, but when I square a number, Andres, what do you think?
Like multiply it by itself.
Right. Everybody say that. When you square, write it down. When you square a number,
Telling you, you multiply
you
it by
are
itself.
multiply by itself. So Kramer squared is Kramer times Kramer. Penny squared is penny times penny. What about in this case, we do 4 squared. Who knows 4 times 4? 4 squared. Go. Say it out loud.
16.
It's 16. So guys, 16 times pi is our answer. Now, some people, when they hear 16 pi, they immediately say 48.
So squaring is
Why do
like
you think?
doubling by itself.
Multiply it by
Wait,
itself.
Who?
So
Go
like
ahead.
8.
Oh, Will, do
square
you have a question, buddy? I'd love to have your question.
No,
Ask him.
Go ahead, buddy. So
I
you
don't
were
have any
saying,
questions.
but you were saying that 4 squared is really doing what?
Just multiplying 4 by 4.
Yes, that's exactly right. Now, I have to tell you guys, there is one number that I do not like to teach when I'm teaching squaring. Does anybody know what number that is? What is the hardest number to teach when you're teaching squaring? Mark?
0?
Well, I like what you said, but I think that if I wrote down 0 squared, which William would say is 0 times itself. Everybody, what is 0 squared? Say it out loud.
0.
But there is another square that's harder. It's just hard to teach. Gabby?
Maybe 1 or negative numbers.
Negative numbers can be challenging, but 1 squared is 1 times itself, which is what, everybody?
1.
The number I'm thinking about, folks, is 2 squared. And the reason I don't like 2 squared is because when students see 2 times 2,
Oh, they think it's
do you know what they think? They think that, well, they think that they're multiplying the base number 2 by the exponent 2. And so kids learn and they always go B times M. Now, it happens to be true with 2 squared. Now, you know what kids do next? When they see 3 squared, you know what they say incorrectly?
6.
They say 6. And when they see 4 squared, they say
They
incorrectly
say 8.
8.
8.
So what
Because
I
they're
want to tell you-
thinking that 4 times 2.
Go ahead, Alexander.
Because they think when they see that symbol, the number one thing that comes to mind is 4 times 2.
Right. Now,
And that's why they say 8.
so what I want you guys to learn right now is never, ever multiply the base number by the exponent. So never, ever, ever multiply the base number by the exponent. And if you remember that one thing, it will save you years of wrong answers. And I think you'll really, really like it. Now, let's go back to our little volleyball. So the volleyball has a diameter of about 8 inches. So therefore its radius is 4 inches. Now, when we do 16 times pi, why do a lot of kids say 48? Who can tell me why they answer 48? Mark?
Because 16 times 4 is 48.
16 times what?
4.
No, 16 times 4 is 64. You're really close. Sarah?
3. I actually have a question for the squared. When you square a number, do you always use the same like marking to show you're squaring it, or is there different ways of doing it?
Well,
Because you put the little 2 next to it, but is there any time you ever do like a 4 next to it, let's say?
oh, yes. Sarah, that was a magnificent question. Sarah basically said, can the exponent, the m value, remember we were talking about b to the m power, can that exponent ever be bigger than 2? You bet. And Sarah, that is called 2 to the 4th power. And everybody write this down. 2 to the 4th power equals 2 times itself, times itself, times itself. How many times?
4.
4.
4 times. And therefore, who can say what is 2 times 2?
4.
What is 4 times 2?
8.
And what is 8 times 2?
16.
16.
And that my friends, is 2 to the 4th power? So Sarah, that was an awesome, awesome question. Now, Raymond, why do children often say that the area is 48 when they see 16 pi? You'll have to unmute
Because
yourself.
they already think that it's 16 times 3.
Right. By the way, somebody is humming right now. If they can stop humming, that'd be great. So 16 times 3 equals 48. And that's why kids incorrectly will say 48. But however, 48 is pretty close. What would be a better estimate than 48? To say 16 times what number, guys?
22/7.
Yes, because you know that 22/7 is very, very close to 3.14, 3 1/7, 22/7. Now, multiplying fractions. When we multiply fractions, everybody, we multiply a what? A cross. A cross, not cross. We multiply a cross. So we multiply 16 times 22, and then we multiply 7 times 1. Now, who thinks they know which one is easier? 16 times 22 or 1 times 7? On
1
3,
times
say it.
7.
1, 2, 3, go.
1 times 7.
1 times 7.
Is what?
7.
Exactly. Now all we have to do is multiply 16 times 22. Now there's a lot of really fun ways to do that. We can use distributive property. We can do 16 times 20 plus 2. Come on, guys. What is 16 times 20? Come on. 2 times 16 is 32. Tack on a 0, 320.
320.
And what is 16 times 2?
32.
32.
What's that spell?
352.
352.
Nice job. Now, what about 22 times 16? Partition. Now we can do 22 times 10 is?
220. 220.
And 22 times 6 is? Think 20 times 6 and 2 times 6. Right? You could just use distributive property with 6 times 22. 120 plus 12 is what, guys?
132.
And 220 plus 132 is also 352. Now, the last way that I want to talk about it is using standard algorithm. And I really want you guys to begin to use standard algorithm. Some of you already know it. What we're going to do is we're going to get a rhythm here. Are you ready? 2 times 6 is?
12. 12.
2 times 1 plus the carry. 2 times 1 plus the carry.
3.
Go.
3.
Now this 2 is really a 20. So we have to make a placeholder. And I usually make little smiley squares. That's really a 0. But since this is a 2, isn't it the same 32?
Yep.
And when we add them, what do we get?
52. 352.
152.
Same answer. Now, what if we did it the other way around? What if we did 22 times 16 and did 6 times 2 is? Say 12.
12.
And 6 times 2 plus 1 is?
13.
13.
Placeholder for the 1. And 1 times 22 is just?
22.
Add them together and what do you get?
352.
Now, everybody, we were very, very successful in multiplying 16 times 22. The next thing we need to be successful at is dividing 352 by 7. And it's a lot easier than it looks because everybody, 7 goes into 35. How many times? Go.
5.
And 7 goes into 2 how many times?
0.
0.
7.
With what left over?
2.
2 what?
2 sevens.
2 7.
Bingo. And when I wrote down 50 and 2/7 inches, square inches, do you see that about oh, actually, wait, why did I write 8? Why? Oh, I see. Because there are 8 of these kind of funny little triangles, but it's really 44 plus 6 and 2/7. So the remaining blue sectors, the 8 of them make up an area of 6 and a little more. And that's the way we find the area of a circle. Now, I'm gonna go ask everybody to please go to page 6. Go to page 6. And I think what I'd like to do is I'd like to choose a pretty simple sphere. Let's choose a golf ball. Okay, now a golf ball is approximately 2 inches in diameter. It's a little smaller than that. Now, who can tell me the radius of the golf ball now? On 3. 1, 2, 3, go.
1. Approximately.
1 inch. Now, all we now have to do is take the area equals pi times the radius squared. Who knows what 1 squared is?
1.
Say it out loud. It's 1.
1.
Pi is approximately 3 1/7. And so therefore the area is approximately what?
3 1/7.
And all you need to say is square inches. Now, can I ask a question? When you look at a ball, doesn't a ball have many circles that can be cut through it?
Yep.
Yep.
But which circle are we talking about? Gabby?
We're talking about the circle that's in the very middle of the ball.
Now,
So
who
if you
knows
took
what
a
it's
measuring
called?
tape, wait, I think I know.
Wait, I know.
The great
Go ahead,
circle.
say it.
The biggest
Great
circle.
circle.
Yeah, now guys, right now, I am actually looking at a great circle. Now, the great circle that I'm looking at, I really don't want to hurt your eyes, but if I were to move this computer over just slightly, you would be able to see the great circle that we call the sun. Now, we don't see every circle. We only see the largest circle of any sphere. And that is how we find the area of that great circle. Now, who would like to choose another sphere for us to try to do together? And I'm going to go with Jesse.
A tennis ball.
All right, let's go measure a tennis ball.
Tennis.
So a tennis ball is about close to 3. So everybody write it down. A tennis ball is close to 3 inches in diameter. So what do you think the first thing we need to do to find the area of the great circle?
What do you find the radius?
Yeah, everybody raise their hand if you can tell me the radius of the tennis ball with a diameter of 3 inches. Raymond, are you thinking about this? Isabella, what do you think? What would be the radius of the tennis ball with a diameter of 3 inches? You're going to have to chop 3 and a half. And you might want to think about it as 3 equals 2 plus 1. What's half of 2? What's half of 1? And then put them together. So Isabella, what's half of 2?
1.
And what's half of 1? What's half of 1? Isabella, what's half of 1? Anybody want to help?
Me.
Go ahead, Raymond. Go ahead, Raymond. Come on, help out. Keep yourself unmuted.
What do you say?
Well, you got to listen. That's what I want to make sure you're listening, and I don't think you are. I'm trying to find out the radius of the tennis ball. Okay, Mark, help us out.
It's 1.5.
Yes, it's 1.5 or 1.5 or just 3 halves. Isabella, do you see that? It's 3 halves. Now, we have to now do the area equals. There's something very loud in somebody's background. I'm going to try to see if I can find it and then mute it. If it's you, there's some like loud like television or somebody talking. If you can mute yourself, that would be amazing.
That's an echo of you.
I don't know.
Yeah, that's
Okay.
an echo of you.
Here we go, guys. Pi times 3 halves squared. Who can tell me what is 3 halves squared? That's 3 halves times itself. Anybody have any ideas? Remember, we talked about multiplying a cross.
1.5.
A cross. Raise your hand, please. Don't call it out. Aunt Arish?
10.5.
Say it again, please.
Wait, no.
Okay, Gabby.
9/4.
Yes. Everybody, it equals 9/4. 3 times 3 is 9. 2 times 2 is 4. Now, all we have to do is multiply 9/4 by 22/7. Everybody write that down. Now, who has the echo at their end? Can anybody raise their hand and tell me, yeah,
I
it's
think that might
me.
be Raymond.
Raymond. Okay, Raymond. Oh, guess what? That was it. That was it. Raymond, you got to keep yourself muted. Sorry about that, buddy, but you have a major, major echo. Now, we are doing 22/7. Oh, wait a minute.
Uh-oh, it's your
Oh,
echo.
no.
It's your
Raymond
echo.
did it again. Okay, there we go. So, 22/7 times 9/4. Now, there is something special we can do here, everybody. Before we multiply across, we are going to, and Raymond, I want you to keep yourself muted, buddy. You got to keep yourself muted now, all right? Because you've got this echo. Everybody, can you simplify 22/4? Don't say it out loud. Think about how you could simplify it, cutting it in half and half. Who thinks they have 22/4? If you have it, raise your hand. Go, Sarah. You're gonna have to unmute yourself, Sarah.
To simplify it, would it be 11 halves?
Wow. Does everybody agree? Isn't 22 divided by 2 11? And isn't 4 divided by 2 2? Yes. And so therefore we can write an 11 above the 22, a 2 below the 4, and let's multiply 11 times 9. Everybody say it on 3. 1, 2, 3, go.
99. 14.
99/14. Now, everybody, how many times does 14 go into 99? And one way we can think about that is we can count by 14s. 14, 28. Oh, that's Raymond. Okay. 40. Come on, guys. 42, 56,
70,
70,
84,
84.
98.
Oh my God. How many times, guys? How many times? Say it out loud.
7.
7.
7
They have one left over.
and 1 left over. So that means that the area of a tennis ball is, and Raymond, you got to keep yourself muted here now, buddy, is 7 1/4 square inches. 7 1/4 square inches. Now, the next time you look at a tennis ball, try to see if you can see how that would be 7 1/4 square inches. Now, there is something we're not going to have time to do today, but I think it would be a lot of fun. Notice that the sun has a diameter of 865,000 miles. So when I look up at the great circle that is the sun, I am always trying to think, how big? How big? So I did the calculation for you, and it's a lot of fun. The diameter was 865,000 miles. let's do that together. 865,000 miles. We have to cut that in half. Everybody, let's do it together. Unmute yourself, except for Raymond, because of the echo. Let's do it, guys. 2 goes into 8, go.
4.
4,
4.
Into 6,
3,
into 5.
2.5.
The
We say 2 remainder 1. 2 goes into 10,
5.
5.
5,
into 0.
0.
0, 0.
And there it is, guys. The radius of the sun is 432,500 miles. Now, all we have to do to find the area of the great circle of the sun, we have to do pi times 432,500 squared. Now, that looks pretty difficult, doesn't it? But let's look at the way Mr. Kramer did it. I wrote out 432,500, but I casted away the zeros. There are 4 zeros that I pushed to the side. Then I started using my standard algorithm for multiplication. 5 times 5 was 25. 5 times 2 plus 2
6, 9.
was 12. 5 times 3 plus 1, 16. 5 times 4 plus 1, 21. And if you notice, guys, I had to do that with the 2, the 3, and then the 4. But each time I would have to add on an extra placeholder. And those placeholders are zeros, but it's important that you write them down. And I got the square of 432,500 at 187 billion, 56,250,000. Now, after I did that, then I had to take that number and I had to multiply it by 22 sevenths. And oh my God, was that a lot of fun. So multiplying by 22, I did the same thing. Remember to bring back your zeros. If you cast them away, all 4 of them, at the end, you bring them back. Here I casted away another 4 zeros, and then I brought them back. And I finally got a number, which was 4.1 trillion, which I then had to divide by 7. And when I did that, everybody, I got a number. Now, if you think you can read the number of square miles that is the great circle of the sun, please raise your hand. I'm going to call on one person to read the number that I've written here, starting with 587. Who thinks they can read that number? Kelsey, we're going to go with you. Gabby, you're going to be a backup. Go
Wait,
for it,
can I
Kelsey.
do it?
Who's the can I do it?
Jesse.
587,
Well, hold on. Kelsey, you go first. Go ahead, honey.
587 quadrillion, 891 million, 71,428.
And
Billion, thousand.
and what about you, Gabby? Nice job, Kelsey. Go, Gabby.
587 million.
No, not million. Billion. Good.
891 million. 71 1,428,147 square miles.
Wow, awesome. Guys, the best part
Okay,
about
can
what
I do
Gabby
it?
just did, hold on, Jesse. The best part about what Gabby just did is she said square miles. Jesse, you be the last, buddy.
587 million, 587
Billion, buddy.
billion,
Billion.
891 million. Wait, can I do it? 587 billion, 891 million, 71,422 fourth seventh square mile. 428 4/7 square miles.
Everybody, round of applause for the beautiful mathematicians here. You guys are amazing. You can do almost anything. The possibilities are endless. I cannot wait to see what you come up with next week. All right? I'll see you guys. Say goodbye to your friends. Say we'll see you next week.
Bye.
Bye.